This video file is recorded in Sabancı University during the recitations for the CS201 Introduction to Computing course, as it was given in the fall 2016 semester.
For the ones that just came, we should write a program that is going to calculate the raise of the salaries. Namely, let's say that if a worker has a salary that is in this range, meaning greater than 0 and smaller or equal to $1,000, he should have or she should have a raise of 15%. If it's greater than 1,000 or smaller and equal than 2,000, the raise is 10%. If it's in this range, it's 5%. And if it's greater than 3,000, the raise should be 5%, 2.5%. This raise is going to be incorporated in this formula, and the new salary will be the old salary plus the salary multiplied by a raise percentage. Okay? So we are going to write this code from scratch. Basically, it should look something like this. Let me fix the font again. So enter your salary. If my salary is $1,000, and you see, if it's 1,000, I should get an increase of 15%, because if it's smaller or equal to 1,000, it's 15%. So if my salary is 1,000, what should be my new salary? 15% of 1,000 is how much? How much, yeah? Yeah, the rate should be 150, but the overall salary is 1,150. Okay, the raise is 150, and you see the formula is the old salary. You see it here. It's the old salary plus the raise. So it's going to be 150. We should write this piece of code. Okay. You should add the progressive raise point CPP in your solutions and remove everything else. You should add only this one. So we have it here. Now let's do the stuff that we need. Let's not forget the C in ignore. And this is an important example. Return 0. Okay. So we should do this stuff here. How are we going to do that? With if statements. So if the salary is greater than 0 and the salary is smaller or equal to 1,000, the new salary will be blah, blah, blah. Else, if it's not the case, we'll check this one, and this one. Does that make sense? Yes. Let's do it. And we will see mistakes that we can make during this stuff. So, if the salary is smaller or equal than 0, the salary must be positive. Otherwise, if we don't have any mistake with the salary, we should calculate raise one salary. And salary is of type double, by the way. So we go here. Now let's write the code. Can you write something like this? If salary is smaller or equal to 1,000, no, then what do we do? The new salary, according to this formula here, the new salary is going to be this much. Salary equals to old salary plus salary multiplied by the percentage. We had 15%, and 15 is multiplied 15 divided by 100. 15.0 divided by 100. We can put it like this. Okay. Should we print it also? This is, I think, yeah, we should print it also. Let me check. Yeah, we were printing it. So the salary is 1,000. Your raise salary is blah blah blah. Okay, let me print it here. So cout your raised salary is, and I'm printing the new salary. Okay. If it's not smaller than 1,000, we should write else. If it's not the case, else. We are writing in another if. What do we have else? If it's not smaller than 1,000, then let's check whether it's smaller than 2,000 or equal to 2,000. So we are writing this stuff here. Else if salary is greater than 1,000, if you are not sure which one goes first, and or, because sometimes you have and or statements in one if clause, you just write brackets, parentheses, okay? If the salary is greater than 1,000 and smaller than 2,000, and salary is smaller or equal to 2,000, what do we do? Okay, so this parenthesis goes with this one goes with this one, and this one, those two, go with this if. So, if it's the case, then what should we do? We should increase the salary by 10%. Basically, we can just copy and paste this piece of code. Everything is the same, except for this 10% here. We put 10 here. Now, how are we going to proceed? Can someone tell me? Else. If it's not in this range, what are we going to do? Else. So we saw this one, smaller than 1,000. We saw this one. Now what should we do? Come on, talk. If it's between 2,000 and 3,000, that's why we can basically copy-paste this piece of code. Put it here. If the salary is greater than 2,000 and the salary is smaller than 3,000, the increase should be 5%. So we have here 5. Finally, if none of them applies, we can just use else without using an if, because if it's not smaller than 1,000, if it's not between 1,000 and 2,000, if it's not between 2,000 and 3,000, for sure it's greater than 3,000, because you remember we don't allow negative salary. It should be greater than 0. Else, the salary is going to be, your raise salary is, should be 2.5%. Okay? I mean, if you want, you can write it. That's why I'm going to comment it. If salary is greater than 3,000, then we have this stuff here. Okay, do you think this should work? Yeah, that's right. Please enter your salary. Let's say it's 1,000, and I got 1,150. Of course, it works for other values. So it's okay. By the way, those are called, let me write it here, nested if statements. Now let's do the same thing in a different way. Did you get this one? Do you have any problems with this one? So here's the code again. It's very simple and easy to understand. Did you understand it? It's very important to understand. If you have questions, please ask. Let's go with another piece of code. You might say, well, why do we put those else's? We just say, if it's between this range, then the salary is this much. We should not put else, we just say if. What's the difference if we put else and if we don't put else? If we put else, if this first statement, if this guy, the first statement, this if here, is not true, then we go and we execute this else. Okay? If this is not true, we go with this else. If this is not true, we go with this else. But only one of them is going to be executed. Okay? You cannot execute all of them. However, if you don't put else, it might be the case that the first might be true. If you don't have else here, the second if else, the if statement might be true. If you don't have else here, this might be true. So basically you can execute all of them except this one. This one is going to be executed if this if is not true, okay? So if you have else again, this else is going to be executed only the if that is before it is false. But if you don't have else, it checks one by one all of the if statements. Now let's write the code, since you might assume, and in first sight it looks like that. Let's copy paste this function, calculate raise. I'm copying it and I'm pasting it. So calculate rise, let's call it 2. And I'm going to delete those else's. Maybe except for the last one. Or even here we can put this if clause. So do you think it's going to work? Because I'm saying if the salary is smaller than 1,000, if the salary is smaller than 1,000, we increase it 15%. Yeah, I'm doing it with this code. If the salary is between 1,000 and 2,000, then increase it 10% and so on. Do you think it's going to work? Yes or no? Does it make sense without else? I mean, if it's smaller than 1,000, just increase it 15%. If it's between 1,000 and 2,000 in this range, just increase it 10%, 5%, 2.5% correspondingly. So is it okay? Yes or no? Tell it. What do you think? You don't think it's a problem? At first sight, yeah. It should be like that, because if it's 1,000, it's raised as the salary is raised as it should be. So what about others? Do you think it's okay or a problem? Come on. You?
I think we should put else.
Why? You don't know why. Let's run the program. So who thinks it's okay? I think it's okay in first sight. What about you? Who thinks else? You also. Just I'm saying okay. I might lie to you. Who think it's not okay? But you should give a reason why it's not okay. So what's the reason, Ilhan, about you?
Well, I tried it and it didn't work.
You tried. Okay, this is a good way. I mean, you test your program. What about you? Why do you think it's not okay? Yeah? Because you said it's not okay?
Maybe the ranges are not intersected.
The ranges are intersected. I mean, if you see if statements, they're not intersected. Which one? Let's see. Let's run the program. We are going to have a mistake. And we will see where is the mistake. I forgot to call this function. Now I'm going to print here cout. Now the same result without else's. And I'm calling, what was the name of the function? I'll calculate raise to. Calculate raise to, and I'm printing the salary. So this was calculate raise to without else's. Let us run the code. So the salary is 1,000. I have 100,050, which is okay. Now the same result without else's. Your raise salary is. Why do I get the same result again? Oh yeah, very nice. Let me put an end line here and an end line here, and you're going to tell me what has happened. You can use the breakpoints, by the way, but maybe you won't need it right now. Okay, and line also. So I'm running the code. 1,000. Your result is, but the same result without else's is this much. First, I say that it's 1,150. Then I say that it's 1,265. Why? Exactly. So for the first time, we know why it's like that. Let's go and see how let's see the output here. The output here is here. So we are calling calculate raise to. The salary is 1,000. So 1,000 is smaller than or equal to 1,000. This is true. Since this is true, I'm calculating the new salary, which is 1,150. And I'm printing your raise salary is 1,150. Okay? But I go to the other if. And I check it whether it's okay. So what's the salary for the time being? Salary is 1,150. 1,150, is it greater than 1,000? Is it greater? Yes. So this is true. Let's see the other one. 1,150, 1,150 is smaller or equal to 2,000. Is this true? True and true. Everything is true here. So again, I go here and I execute this piece of code. That's why I say I calculated the new raise with 10%, and I say new raise is 1,265. Is this clear? Okay. So since I didn't have else, the compiler is going to check all of those if clauses, all of those if statements one by one. If I had else, if the first one is true, I'm not going to check any else. Okay. So only one should be true. But here, we might make a mistake. This is a nice example of logical mistake. At first sight, you might think, yeah, this should work. But when you are with the salaries at the borders, you can give it 900, 950 the salaries. It still will be the same mistake. But if you give 500 as input for the salary, you won't get that mistake because the range will not be covered. We won't have an intersection. So the salary is 1,000. That's why I'm increasing it with 15%. It's going to be 1,150, which is again, in this range, it's going to be raised again, okay? So pay attention to where you should use else and when you should not use else, okay? Sometimes you might need all of those if clauses. Maybe all of them should be true and executed, but in this case, you don't want to raise your salary again and again and again. It should be raised only once. That's why you should use else's. So pay attention when you use nested else's, as it was in the previous example, and we are using independent ifs, like it's here, okay? You'll need it for your homework. Is there other, how many of you did understand this one? I mean, the most important part of today is this one. Did you understand it? All of you. I mean, if you want, I can go through it again. just to see the difference between if and if else. This is the most important part of today's lectures. Now let's go with something else. Do you think, can you come up with other codes that you might use here that will give a good result? What if I start something like this? I check whether the salary is greater than 33,000, then I print it. Then check whether the salary is smaller than 3,000, smaller than 2,000, smaller than 1,000, and accordingly, I raise the salary. Can we do it like that? Of course, we can do it like that. So just let me write another piece of code. I'm going to call it calculate raise 3. This is called, how did we call it in the lectures? Bottom top. Starting from bottom, from the low salary to the highest salary. Bottom to top approach. So we first check if salary. We don't have to check the ranges actually, because here you see we check the ranges. Is it between this and this? We don't have to do that. We can do something like this, and it makes sense. It's okay. There's no any mistake here. If the salary is smaller or equal to 1,000, then what I'm doing this piece of code. So I'm just going to copy it and paste it here. So I'm raising the salary correspondingly. Else, okay, you're welcome. If, what else? The salary is smaller or equal than 2,000, then I'm increasing it with 10%. So copy. Because I know if it's not smaller than, only one of them is going to be executed because of those else's here. Again, let me copy paste this guy. Copy. Else if the salary is smaller or equal than 3,000, then the increase should be 5%. And finally, else if, even we shouldn't put this if here, but because if it's not smaller, it's not smaller than 1,000, smaller equal to 2,000, smaller equal to 3,000, and I know that it's greater than 0, for sure it's going to be greater than 3,000. So I can comment this if here. And I'm going to increase the salary with 2.5%. Now let's see if it's working or not. Do you think it should work? Yes or no? Come on. So you saw this piece of code. This is called bottom to top. We start with this salary. I don't have to check whether it's between 1,000 and 2,000. Just I'm checking it if it's smaller than 2,000. If it's smaller than 3,000, can this guy be smaller than 1,000 or not? Here. No. Because if it's smaller than 1,000, this statement is going to be executed, this block. If this is true, I'm not going to check this else. Hence, I'm not going to check anything till the end. But if this is not true, this means that this guy, the salary, for sure is not smaller or equal than 1,000. It's bigger than 1,000. How much? Let's go and check. So it's not smaller than 1,000, so I'm checking. Is it smaller or equal than 2,000? If it's not, I'm checking here. Only if it's not smaller than 2,000, I'm going here. Only if it's not smaller than 1,000, I'm going here. So if it's not smaller than 3,000, then I'm going to print for sure it must be greater than 3,000. Okay? Does it make sense? Just because of those else's, I'm going to execute only one of those blocks, which is what you want to do. So you see, I don't have to write this range here, greater than or smaller than or blah, blah, blah. Of course, it's not a mistake, but usually engineers wants to write codes with smallest amount of lines and words possible. If you don't trust me, just let's print this one. Now the same result with nested else's, but this is the bottom to top approach. So I'm going to execute it again. No, because I called salary 2, I'm going to call calculate raise 3, not raise 2 here. So I'm calling this function. Let's see how it works. So the salary is 1,000. You see, your raise salary is okay. Without else's is this much, but with nested else's, bottom to top, is the result that we wanted to achieve, okay? We have another approach. That approach is called top to bottom. Basically, so let me just copy paste this stuff. Basically, we do the opposite thing that we did here. We start and check whether, so we started here with 1,000. We do the opposite here. From top to bottom, we check whether it's greater than 3,000. If it's not, whether it's greater than 2,000, greater than 1,000, and so on. But we use else's here. You see we have the red dashes because I cannot give the same name to other function, given I have the same parameters, okay? If I have different parameters, then I can give the name I want. So calculate raise 4. I can start something like this. If salary is greater than 3,000, then what I'm going to do, if it's greater than 3,000, then I'm going to print this stuff. Else, if the salary is greater than 2,000, where are we now? If it's not greater than 3,000, we should check whether it's greater than 2,000. So we are here. Greater than 2,000, but for sure not greater than 3,000. So it's between 2,000 and 3,000, since we check for 3,000 here. So if it's greater than 2,000, I'm going to raise it for 5%. So it's 5.0. If it's not greater than 2,000, let's check it if it's greater than 1,000. So I'm printing the code. We raise it, I think it was 10%. We're going to write 10.0. And finally, even I shouldn't write this if here, but it's not a mistake if I write it. If the salary is greater than 0, and it's always greater than 0, then I raise it for 10%, 15%. Okay, can you tell me? So if the salary is, let's say, 4,000, is there any chance that I'm going to execute this piece of code, this piece of block? No, because the first one is going to be executed. This 4,000 is greater than 3,000. So we'll have a raise of 2.5%, and I'm not even going to check those else's. Okay? So this is another way of doing things. If you don't trust me, but I know that you do, although I would be grateful if you don't, you should ask proofs from me, because I'm a human being. I might make mistakes. So bottom to top, top to bottom, calculate race 4. I'm running the code. I'm giving the same input, and you see that top to bottom still gives the correct result. And we saw why. I just tested it with 1000 since it is in the border. If I do it with 2000, it's also in the border. You see we have mistake here without else's. Otherwise, everything is fine. Of course, if I put something which is not in the border, like 1500, everything is correct. Even with the without else's. Everything is 1650. Why? Because the ranges are not intersected. We don't go to the other range when we use else's. Any question about this one? Am I going too fast, or I'm okay? I'm okay. Should I go faster? No. Okay. If I'm too slow, just tell me. Also too fast. Now, you will have the codes. If you didn't write them, if you understood it, it's the most important part to understand it. You will have the codes. I just wanted to show you the logic, the syntax behind if and else, and the logic, what will happen if you use if without else's, and so on. Now there is something that is called precedence. Maybe this will be our last code. We talked about this issue like two weeks ago. But let us talk about it again. Okay. Precedence or priorities. Very often, you'll see mix of operators in the same statement, like modulo, divided, multiplied, plus, minus, blah, 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 and, or, in one statement. And of course, just as it is the case in ordinary math, you have precedence, you have priority. So always when you have addition and subtraction in one statement, always you execute when you have multiplication and addition, you execute the multiplication. So if you have multiplication and addition, multiplication has priority over multiplication. It will be executed first. Of course, the biggest priority are if you put if you're not sure about which one has precedence, which one has priority, always put brackets, parentheses, okay? If you're not sure. Because even I cannot remember this table. Yeah, I know that addition has priority over multiplication, and multiplication and addition, subtraction, and priority have priority before those operators, but I'm not sure about logical operators and or, which has a priority, and or. That's why sometimes I put brackets. Now we are going to see some sentences, some statements, and we are going to evaluate them in accordance. So, here are the statements. Let's see how it's working. The first statement. So pay attention to this one. We have 2 multiplied by minus not 0. This is the exclamation mark. Before going to see how it's working, just let me tell you that if you have if clauses, they should be either true or false. Sometimes true, especially in C, but in C++ this also works, is written as 1. And false is written as 0. And I'm writing 0 like this to distinguish it from O. Okay? So if I have a statement here to evaluate, if it's true, we have 1. If it's false, it's going to be 0. Sometimes if I have not, false is always the 0. And everything else is true. So if I have 1, 2, 5, 100, and so on, it's evaluated as true inside this if. Okay? The negation, what's the negation? If a statement, negation is written something like this. It's read not. If a statement is true, if I put this exclamation mark before it, in front of it, it's going to be, if it's true, it's going to be false. If it's false, it's going to be true. Okay? So inverses the value of the Boolean variable. So again, 0 means false. This guy means if this is false, it's going to be true. And true is usually evaluated as 1. But even if we have 2, 5, 100, or whatever, besides 0, it's going to be taken as true from the compiler. Now let's see how it works. We have this expression here. And let's check the precedence table. Okay, it's here. So, this guy here is not subtraction, this is the minus sign. We have subtraction here, and we have the minus sign here. Okay? So which one is going to be evaluated first? Those have the same priority. This guy here, the logical not meaning what I said, is going to be evaluated first. That's why the result will be the following. It's 2 multiplied by minus, not 0, not true, meaning false. This is like saying, I am 15 years old, and the negation of it, if I put this sign, I am not 15 years old. Okay? So if the statement is true, it's going to be is false, and false is 0. The opposite of false is true, and true is what? 1. Okay, and see here, associativity, right to left. Right to left because this is on the right side, and this is on the left. So I take this one, and this is to the left. Right to left, it's 1. Also right to left. Then we have the minus sign. This is not subtraction, this is the minus sign. That's why this is going to be evaluated as 2 multiplied by minus 1. And how much is this? Minus 2. Exactly. This is it. So here how it works. Precedence. With red color, you have those operators that have the priority, the precedence. So we have the exclamation mark, the not, logical not, then the minus, then the multiplication. Let's go with this guy here. So this is our second statement. Not 0 and 5 modulo 4 plus 5. 5 modulo 4 plus 5. Yeah, this is it. This is equal to, let's see. I'm starting again with this not here. So not 0 is equal to 1 for the same reasons. And 5 modulo 4 plus 5. Now, we have and, modulo, and addition. This is addition. Which one has priority? Come on, tell me. Which, we have 3 operators. This one, and this one. Which one has priority? Has the precedence? Which one of them? You see here. I mean, we start. These are with the highest priority. Go to the lowest priority. Modulo. Yeah. Modulo. Then we have addition and logical AND. So modulo is going to be executed first. That's why we have 1 and 5 modulo 4. How much is that? 1. Because the remainder is 1 plus 5. Then what do we have? We are left with and addition. Which one is going to be executed first? The addition. So we have, this is equal to 1, and 1 plus 5 is 6. Now 1 means true. 6 also means true. So true and true, how much is that? We can see it here. True and true is true. And how does computer write true? 1. It writes it as 1, okay? So true and true is true. The final result here is -2. We have it here as 1. You can see the solution here. So we started with exclamation mark, then modulo, then addition, then logical AND, and finally we got true. Which one do you want to do, the third or the fourth one? Because we don't have time for both of them. Which is more complicated for you? Third or fourth? Third and fourth. Which one? Fourth? Okay. Do you want to vote? How much for the third one?
Can I say third one?
Yeah, but for the third one, you have to just...
I don't see the question.
Okay, this is the third one, and this is the fourth one. Which one do you want to do us right now? Third or fourth? I mean, the trick here is, with the third one, that you have brackets, and always when you have brackets, parentheses, they have the highest priority. So which one do you want to go? Third. How much of you wants to go with third? 1. With the fourth? Most of you. Okay, let's go with the fourth then. You remember this guy. False is for 0, true is for anything else, but the compiler gives 1 for true, always as a result. So the fourth one. Yeah. We have an integer value, k, which is equal to 2. And we have then this expression here, saying that this k is equal to k multiplied by k divided by k. We have addition here, yes, plus k minus k. Am I correct? Plus k minus k. Then we have logical or k, logical and k. Now let's see. This translates to k is equal to, let's see the table. Where is the table? Which one has priority from those? Addition, division, multiplication. So we are going first with multiplication. You see that k is 2. Okay, so here we can write 2 multiplied by 2 divided by, let us write k for the time being. This is equivalent to 2 multiplied by 2 is 4, divided by k is for the time being 2, still 2. 2 plus k minus k, just not to confuse you, that's why we're writing k's. You can put 2's, by the way. So we go. We have this one, this one, this one, this one, and this one. Division, addition, subtraction, logical or logical AND. With which one we should go? We go with the division. So we have 4 divided by 2 is equal to 2. Plus, we have, again, 2 minus k and k, or k and k. This is k is equal to 2 plus 2 is 4 minus k is 2. And k, or k and k. Again, you see that plus and minus, addition and subtraction have priority before and or. That's why we will have 4 minus 2, this is equal to 2, 2 and k. Which has priority now? 2 and or? And has priority. That's why we will have k is equal to, I can write that this k here is 2. So 2 and 2. 2 is true. 2 is also true. True and true is how much? True. And true is written as 1 by the compiler. So I have 2 or 1. And this is 2 or 1, true or true. True or true. This is true. So k is going to be 1. And this is how it works. Okay? Just pay attention to those red signs, meaning we start with addition, then multiplication, division, addition, subtraction, logical and, logical or, and so on, until the end. Because those have the precedence. If you don't trust me, but I know that you trust me, I've written a piece of code. Maybe you don't have it, but if you want it, you can write me. So this is called the precedence. I'm going to copy it, put it to the Solution Explorer here. I'm going to remove this guy and add the newly. So where's the precedence here? This is it. So you remember this one? The first one, 2 multiplied by minus exclamation mark 0. Here it is. And its value is this much, okay? Then you remember this one? Here it is. I'm writing it as a string, and then I'm evaluating it. I'm writing its value. And the last one that we just chose, this one, which starts with k equal to 2. So here I put k2, I'm evaluating k, and I'm printing k here. So let's see the output. You can do it yourself also. For the first one, we have -2. We got -2. Second one is 1. You see 1. The third one is 0. We didn't do it. But you can see it. It's easy. And the third one is 1. We saw the 1 here. Okay? So this is it. If you want this code, just email me and you can get this. But you can do it yourself. You can see it. Just copy, paste it, and do it. Any question? This is about precedence, about priorities. Questions? No questions. Let me give you some hints about your homework. Let me tell you what you should do. You have approximately 1 week. Your homework was uploaded, by the way, 2 weeks ago. So this is your homework. And yeah, let me execute it in front of you. Okay. I'll take just like a couple of minutes more, nothing else. So there are some sample runs. You have sample runs. You have a vending machine. And this machine sells only 3 types of products. Those products are the following. Bottled water, which costs 1 Turkish liras, biscuits 1.75, and chocolate 2.15, okay? In the beginning, you give the amount of money. You give your name. For instance, my name is Artrim. And you give the amount of money you have. Let's say that I have 37.24 Turkish liras. So 37.24. This is double. This is what you should. What do you want to buy? I want to buy 7 bottles of water. That's why I give it 7 here. Then I want to buy 8 biscuits. And I want to buy 4 chocolates. This is what I should take as an output. So you bought 7 bottles, 8 biscuits, 4 chocolate bars. The remaining money is 7.64. I mean, out of those 37.24, when I buy all of those with the prices you saw, you should have the charge, the change of 7.64. You call it para üstü, I think, in Turkish. Okay. And the way the monies that you're going to receive is the following. You will have 7 Turkish liras. Then you will have 150 kurush, which is cents, 150 cent. 1 10 kurush, 1 10 cent, and 4 1 kurush, which is in all 764. Okay? Let me give another example. So let's say my name is, I don't know, Adnan. And how much money do I have? 47.13. 47.13. And what do I want to buy? 894. 8 bottles of water, 9 biscuits, 4 chocolates. Okay, you didn't saw the input, but the output, but it should be something like this. So if you buy all of this, your remaining money will be this much. This is the output. And you should pay it, so 14, you should give 14 Turkish liras and 78 cents. You will give it 14 liras, then 150 kurush, 125 kurush, and 31 kurush. So if you can pay everything with Turkish liras, you pay as much as you can. Then you go to 50 kurush, 50 cent. You pay as much as you can. Then you go to 25 kurush, 25 cents. You pay as much as you can. And finally, you go to 1 kurush, and you pay as much as you can. Sometimes you can have something like this. There are some limitations. The lowest amount you can take is 0, and the highest is 10. If you want to buy 12 bottles of water, you'll get something. You can't request more than 10 of each product, 10 of each. If you want to buy something, 1 is okay, but if you want to buy something negative, it makes no sense. You can't enter a quantity below 0. Okay? And you're not going to process that request. Furthermore, if you give 2, 1, and 121, again, you can't request more than 10 of them. Joseph has only 2.95 Turkish liras, or dollars, and he wants to buy 3 bottles, but he doesn't have enough of money. That's why you can buy 3 bottles of water, but he can buy 2, because there are 2 Turkish liras, and he should get 0.95 back, and it will be paid in this manner, okay? Did you get the homework, what you should do? You should do it using if statements. You shouldn't use while, for, if you know what it is about. Only if and else. And you should use functions also. If something is repeated, use a function. That's why you have a function. And be aware, during one sample run, you should twice give your name and process your request. You should twice do the same thing, okay? During one sample run. You saw it previously. I give a name, give the money, I'm processing. Again, I give a name, give the money, and I'm processing. So you should do it twice. Write comments also. Nothing else except if and else. Yes?
They want more than one user. Can't you just loop the whole thing?
We don't know loops for the time being. That's why you're not going to use loops. But yeah, it's easier with loops, but we want you to learn if and else. I know it's a bit hard. That's why I start doing it from today. Yeah, the first homework was just to lure you, just to warm you up for what is going on. And the homeworks will get harder and harder, okay? So pay attention to this stuff. Questions? We are shy of 2 examples. We didn't do 2 examples, but we will do it next week. They are short examples. Yeah. Okay, you can sign the attendance and you can go. Class is dismissed.